Hello everyone, it's Benny, and today we're going to be talking a little bit more about the world of 3D. And more specifically, we're going to be talking about how you can move around in 3D, which is a little bit more of a challenge than you might think at first, because OpenGL doesn't really have a system built in that handles that for you. So, we're going to be talking about that. And before I go any further, I should mention that we're going to be basing this off the code that we started in video 7. So if you have not followed that, you can either follow along that and get the code, or I'm going to be posting the link to the code from video 7 in the description, so you can just copy that and then start from there. So with that all out of the way, let's go ahead and get started. So, the first step in getting movement in 3D is considering how you've implemented your 3D system in the first place. Now, in our particular case, we set up a camera class that creates essentially what you'd think of as a camera, and we're doing all our 3D through there. We're using the camera to set up the three-dimensional viewing and making sure everything looks 3D, and then we're just drawing everything like normal after that. And that's the way we're setting up 3D, and I think this is probably the easiest way to set up 3D if you want to implement movement. But if you've done it a different way, you should be able to figure out how to adjust this system to fit your needs. So, the first thing we need after we have our system set up is we need to implement some methods for moving our view around. Now, in our particular case, we have a camera class which handles the view, so we're going to be doing all of our movement in there. So I'm going to go over to the camera class, and at the bottom, I'm just going to create a new method. And it's going to be called public void move forward. And what this method should do is it should move the camera in whatever direction it's facing. So, if I just quickly go over here, you'll notice that right here where I initialize the camera, I never actually change its rotation. So in this particular case, moving forward will always be increasing the z-axis. So I'm just going to start there, and then from that point we'll sort of expand this method to incorporate everything it needs to account for the different rotations. So the very basic version of move forward, if you never change orientation, is just z plus equals some speed. And for now, I'm just going to create an int speed, which is just going to be a temporary variable. I'm going to set it equal to 10. So z plus equals, actually that's probably a little much. I'll change it to a float, and plus equals speed. That makes it useful. I don't use the variable. Create float speed. I'm just going to set it to 0.5f. And we'll see what happens there. Now if I hit run, that won't do very much because I'm not actually calling the move forward method. So in my game loop, before I do any of the rendering stuff, I'm going to get input. And for input, all I'm going to do is I'm going to test if keyboard.isKeyDown. I'm going to test keyboard.key_w, so that's the W key. So if we're hitting the W key, now we're getting an error here because we haven't imported the keyboard class, but if I just hit Control-Shift-I and select OK, then that'll solve that error for us. So, again, back to our if statement. If we're pressing the W key, then we just want the camera, so cam.move forward. And this should cause the camera to move forward if we're hitting W. So, if I just hit run, and wait, now, you'll notice that I'm moving a little bit too fast, so I'm going to decrease my speed to 0.01. We'll see how that works out. So I try again, and there. You notice I have a very basic way of moving forward. Of course, this doesn't account for any orientation, but it works. And while I'm at it, I'm also going to create a public void move backward, which I'm actually going to move this variable out. And again, this is all temporary code, so I'm not going to worry too much about being clean about it, because obviously the system's not going to work once we throw rotation in. But I'm just going to add in backwards, so that we can also move backwards if we want. I'm going to do this is I'm just going to go back to where I had the forward action, and below I'm going to test if keyboard.isKeyDown keyboard.key S. So S to move backwards. And for hitting that, we'll do cam.move backward. And now we should be have a way of moving forward and moving backward, but we don't because I forgot to change this plus to a minus. It's a little bit of a silly mistake, but oh well. And there. Now we can move forward and backwards towards our rotating cube. Now one thing is that even though we have 6 sides to this, we have no way of distinguishing them. It's just this orange blob that appears to be in the shape of a rotating cube. So just to really quickly fix that, I'm going to go to all of our faces. I'm just going to, above every face, call GL color, free F. I'm going to give each face its own unique color. So the first face, the front face, I'm going to make red. So that's 100. That will be red because that's 1 red, 0 green, and 0 blue. And for back face, I'll do 1 green. So that will be not red. It will be green, of course. And last one, in the bottom face, I'll do blue. Now for the top face, I will do full red and full green. For left, I'll do full green and full blue, and for the right face, I'll do full red and full blue. And that should give us 6 different colors for every single face. When I hit run, well, you'll notice our cube has their own faces. It's a little bit odd. It's not exactly what we're looking for, but that's actually a slightly different problem, so I'm not going to worry about that in this particular video. But just know that's not as much of an issue as it probably looks like. Actually, I really should probably fix that, shouldn't I? Alright, fair enough, I'll fix it. You got me. So, this issue, it doesn't actually have anything to do with our colors or the way we drew the cube. It actually has to do with the way that we set up 3D. And the reason is, even though we're drawing in 3D perspective, we aren't actually doing any calculations to maintain the depth. So OpenGL doesn't really know what to draw in front of the other, and it gets this weird, overdrawn cube that's not exactly what we're looking for. So all we have to do to fix this is we just have to enable depth calculations. So first thing we have to do is in our camera, which is where we're setting up 3D, just go under the init projection method we have, and just do GL enable GL depth test. And this will enable depth calculations. Now if I hit run, this will make our screen go completely black. And as you can see, it has. And don't worry, it hasn't crashed our program or anything. The issue is the depth test uses depth buffers, and we have to clear them at the start of every frame, or it will start overwriting another and it will get confused, and the end result is our screen goes black. So, just go to where we're doing GL clear, and we can use the bitwise OR, which is just a single line thing, and do, further than just clearing the GL color buffer bit, it will clear GL depth buffer bit. And there. And in case you're wondering about this is just, it's like any other OR, but it's something called the bitwise OR, because I actually don't want to get into that in this video, but if you want to learn more about the bitwise OR, you can go ahead and look it up. I don't want to bother explaining that in this video. But now if we run, you'll notice that all of the colors are now showing up like we expect. So there, that's one problem solved. So, now let's get back to the task at hand. I'm going to go to the camera class, I'm going to implement rotation. And the reason I'm going to implement rotation is because that's what's going to screw up these move forward and move backwards methods. So, I'm just going to create a public void called rotate y. And here we're just going to rotate on the y-axis. And I'm going to take in some amount we're going to rotate. So I'm going to take in just float amount. And all this is going to do is it's going to take our rotation y and add the amount. And that's it. So what we're going to do is, in the place we're doing all of our input stuff, I'm going to add another input. It's going to be if keyboard.isKeyDown, keyboard.key underscore A. Then we'll do camera.rotate Y, and we're going to rotate by 0.1 f. And then below that we'll do keyboard.isKeyDown, keyboard.key D. So we're just doing standard WASD thing here. We're going to do camera.rotate Y, this time negative 0.1 f. And now, if I can still move. If I hit A and D, it rotates, but they're actually backwards. So I'm just going to flip them around. I'm going to change the negative from D to A. And now rotation should be working like expected. Simple enough. The issue is now if I try moving forward, it's not exactly moving me forward anymore. And this is because our movement methods aren't taking any account whatsoever of our rotation. So that's our next step. Although, really quick, I'm just going to change these move methods to, other than both move forward and move backwards, I'm going to have it move Z, so moving on the Z-axis, which in essence is forward, and I'll just take float amount. And this will also get rid of the speed thing, and I think that'll be, just a little bit easier than the way we have it set up. And now, in our main class, we'll just do camera.moveZ instead. And we're going to move forward by 0.01 f, and camera.moveZ by 0.01 f again, except this time negative. And don't forget semicolons, or Java will hate you, and your program will not run. So there, now if I run, that should do exactly the same thing. Okay, good. So I can move, I can rotate, but again, I need to actually implement proper movement. Movement that takes into account the rotation, that's what I mean. So let's go ahead and do that. So the way we're going to do this is using the definition of the sine and cosine functions. The sine function, by definition, is calculating the y position of a circle based on some angle. So at a 0-degree angle, for example, then your position on a circle will be 0. But at a 90-degree angle, that'll be the highest point on the circle, so your y-coordinate will be 1. And of course, at 270 degrees, that's the lowest point on the circle, so your y-coordinate will be negative 1. And that's all the sine function actually does. So if you didn't know that, there you go. That's what the sine function is literally calculating. And the cosine function is calculating the same thing, except for the x-coordinate rather than the y-coordinate. So that's what we're going to use. Now, in our case, we aren't using the y-axis, we're using the z-axis. So we're going to use the sine function for the z instead of y, because in our case, y is up. We don't want to go up, we want to go forward, so we'll use z. So all we're going to do is we're going to take our amount, and we're going to multiply it by the sine function. And it'll be math.sine to get the actual sine function. And you might be tempted to just directly pass in our rotation y, but the math class in Java does all its math using radians, and we're keeping track of our angles in degrees. So we're going to have to use a method called math.2radians, and we're going to pass in our rotation y. And that, right there, this, see, right here, this will give us the appropriate z-coordinate. So, now all we have to do is the exact same thing for the x-coordinate, again, using the definition of the cosine function. And there. Now, based on the definition of the sine and cosine functions, this should move us in the appropriate direction based on our angle. So if I hit run, and I hit forward, you'll notice something's wrong. We're not moving forward, we're moving sideways. And the reason for this is we're just directly passing in rotation y. If you think of a circle at 0 degrees, that's not facing forward, that's facing sideways. So we actually have to add 90 degrees to this, and that'll just make our angle face forward rather than sideways. And now if I hit run, you'll notice it's working. Now if I rotate, we're now moving in that direction. So we now can explore our world as much as we want on the X and Z axes. So there. We now have our basic complete movement system on the Z axis. So the only other thing I really want to do is I want to change this move method to a generic move method. So I'm just going to do public void move, and instead of just taking in an amount, I'm going to take in float direction, where 1 would be the forward and 0 would be sideways. So I'm just going to multiply that 90 times direction. And now if we want to move on X, we pass in 0. If we want to move on Z, we pass in 1. So now I'm just going to actually pass in direction second, because that makes more sense to me. So float direction. And now, in addition, I'm just going to pass in, for these, I'm going to pass in 1, because we're moving forward. And I'm going to rename them to just move. And A and D, yeah, I guess I can, well, just temporarily, I'm going to comment these out and change it to cam.move. I'm going to pass in, again, negative 0.01f, and this time I'm going to pass in 0. And this will allow me to move sideways. And it should pass in like that. There, now if I hit run, I can move forward, and I can move sideways, even though my sideways is inverted, but that's okay. So now, I'm just going to move that back. And there, we have a generic movement function. And actually, really quick, I'm going to change these back to the movement functions, and I'm going to actually fix the direction, because I'm going to demonstrate something that I got requested, and it's simple enough, so why not? The question is, how can you make it so that the cube suddenly orients itself at 45 degrees if you're trying to move diagonally? So, this is actually simple enough. First off, I'm going to get rid of our rotation code so that we're just commented out at least, and that way our cube is just stationary. It's just a cube now. Now the only issue that I really don't like is we don't have any way to rotate, and I really don't like not being able to rotate, so I'm just going to copy these 2 lines of code right here. I'm going to change it to key left and key right, and I'm going to make these rotate. In this way, I'll just have some way of actually rotating in addition to strafing. And what else is bugging me now is that I also want to be able to move forward with the up arrow key. So I'm just going to add an OR to these if statements and just say it, test keyboard.isKeyDown, keyboard.key up, and nope. And also I'm going to test keyboard.key down. And now I can control with both arrow keys and with the WASD, and I can do really weird things like this. But anyways, back to the topic at hand. What we want to do is we want this cube to rotate 45 degrees if and only if we're moving diagonally. And the first step to this is just testing if we're moving diagonally. So I'm going to put a conditional check right here. I'm just going to test if we're moving diagonally. The way I'm going to do this is going to test if keyboard.isKeyDown. Actually, just to make this a tiny bit not taking up an insane amount of room, I'm going to create a boolean forward, a boolean backward, and a boolean left, and a boolean right. And I'm just going to set these equal to this. And this just makes it so I don't have to retype that code for everything that I'm doing. So I'm going to change this to backward. I'm going to assign backward to this. And this will be left, if left, and if right. This is just going to make our lives a lot easier. So now, again, back to the topic at hand, how do we test if the player is moving diagonally? Simply enough, I'm going to test if, and we just have to figure out every combination that will result in diagonal movement. And that will be if I'm moving forward and left, so that's one way that I could be moving diagonally. And another way, so I'm going to test that, or I'm moving forward and right, or I'm moving backwards and left, or I'm moving both backwards and right. And that should be every combination which results in diagonal movement. And this is where we're going to figure out if the cube should rotate at 45 degrees or not. So, to make the cube rotate 45 degrees, it's simple enough. We just need to use rotate. But the problem is, the place we need to do rotate is in here. Now, one way is I could use some interesting Boolean stuff, but just to make it a little bit easier, I'm going to move it into the matrix. So I'm going to tab these over because NetBeans loves mistabbing things for some reason. And to start off with, I'm going to do GL rotate F. I'm going to make it rotate on X. Excuse me. No, that's the angle. I'm sorry. I'm going to make it rotate 45 degrees on X. So there. And now, if I try to move diagonally, the cube is rotating diagonally, except it's on X, and I kind of actually would rather have it on Y, so I'm going to change that around. So there. And now the cube is suddenly rotating diagonally whenever I'm moving diagonally. Now, one slight issue with this is... Actually, no, that's not an issue. I'm sorry, I was imagining there was a problem in my code that there actually wasn't. So yeah, and right now, one behavior that you might not want if you were doing this is if you wanted the cube to stay rotated 45 degrees once you stop rotating diagonally. And that's actually really easy. The way to do that is just with a Boolean. So I'm just going to right here quickly create a Boolean. We could call it temp, because that equal to false. And actually, instead of testing it here, I'm going to test if temp. If our temp, then we rotate 45 degrees. And in here, we're just going to set temp equal to true. And this way, it'll just make it so that it stays rotated 45 degrees, rather than just suddenly rotating back when we stop moving diagonally. And there. So there you go. I hope you enjoyed, hope you learned, and see you next time.